Chapter 1. The Silver River. For as long as humans have walked the earth, we have looked up in wonder at the hazy ribbon of light arching across the night sky. In ancient China, it was seen as the Silver River separating two lovers. To the Greeks, it was Galaxia's Kyklos, the Milky Circle, from which we get our word galaxy. But for most of human history, we didn't realize we were looking at our own home from the inside out. We live in a city of stars so vast it defies the imagination. If you were to board a spacecraft traveling at the speed of light, 300,000 kilometers per second, it would take you 4 years just to reach the nearest star. To cross the Milky Way from one edge to the other? That journey would take you 100,000 years. Our galaxy is a barred spiral, a colossal, rotating disk of gas, dust, and at least 200 billion stars. We are just one of those stars, an average yellow dwarf sitting in the suburbs, roughly 26,000 light-years away from the crowded, chaotic center. But how did we come to know this? For centuries, we believed Earth was the center of everything. Even when we realized we orbited the sun, we thought the Milky Way was the entire universe. It wasn't until 1924, when Edwin Hubble observed distant nebulae and realized they were actually separate galaxies, that the true scale of the cosmos began to dawn on us. We are not the center of the universe. We are one island in a vast archipelago of trillions. To understand the Milky Way, we must first understand its scale. Imagine our entire solar system, from the sun out to the furthest planet, Neptune, shrunk down to the size of a single U.S. quarter. On that same scale, the Milky Way would be the size of the United States. The distance between stars is so immense that if two galaxies were to collide, it is statistically unlikely that even two single stars would ever actually hit each other. The Milky Way is 13.6 billion years old, nearly as old as the universe itself. It has grown through a violent history of consumption, swallowing smaller galaxies to fuel its own growth. It is a living, breathing engine of creation and destruction. In this documentary, we will peel back the layers of dust and time. We will dive into the supermassive black hole at our core, witness the birth of stars in glowing gas clouds, and look forward to the day our galaxy meets its ultimate fate in a collision with its neighbor, Andromeda. This is the biography of our home. This is the story of the Milky Way. Chapter 2. The Grand Architecture. If you could step outside our galaxy and look down upon it from above, you would witness one of the most beautiful structures in the known universe, a grand, glowing whirlpool of light. This is the grand architecture of the Milky Way. But the galaxy is not a solid object. It is a dynamic, rotating machine made of different layers, each with its own history and its own purpose. To understand the anatomy of our home, we must start with the disk. The disk is where the action happens. Stretching 100,000 light-years across, it is surprisingly thin, only about 1,000 light-years deep. If the Milky Way were a DVD, the disk would be the shiny surface where the data is stored. This is where you find the gas, the dust, and the vast majority of the stars, including our sun. Within this disk, stars move in neat, circular orbits, like cars on a multi-lane highway, all racing around the galactic center at hundreds of kilometers per second. But look closer at that disk, and you'll see the Milky Way's most famous feature, the spiral arms. For decades, people thought these arms were like the blades of a fan, fixed structures that spun around. But that's a myth. If they were fixed, they would have wound themselves up and disappeared billions of years ago. Instead, the arms are density waves. Think of a traffic jam on a highway. The cars, the stars, drive into the jam, slow down and bunch up, and eventually move out the other side. The jam itself stays in one place while the individual cars move through it. In these crowded spiral arms, gas and dust are compressed so tightly that they ignite, giving birth to brilliant, hot blue stars. This is why the arms look so bright. They are the neon signs of the galaxy, marking the spots where new suns are being born. The Milky Way has four major arms: the Perseus arm, the Scutum Centaurus arm, the Normo arm, and the Sagittarius arm. We live in a smaller offshoot called the Orion Spur. It's a quiet, stable neighborhood, tucked away from the more chaotic, crowded inner arms that as we move inward, the flat disk begins to swell. This is the galactic bulge. Here, the neat, circular orbits of the disk break down. In the bulge, stars move in random, elongated orbits, buzzing around like a swarm of bees. This heart of the galaxy is packed with old, red stars, some of which date back to the very dawn of time. It is a place of extreme density. If you lived on a planet in the bulge, the night sky would be so crowded with stars that you could read a book by their light alone. But there is more to the galaxy than what glows. Surrounding the entire disk and bulge is a massive, invisible sphere known as the halo. The halo is a ghost realm. It contains very little gas or dust, so very few new stars are born here. Instead, it is home to the globular clusters, ancient, spherical cities of stars, some containing 1 million suns packed into a space only a few light years across. These are the oldest objects in the galaxy, the fossils of the Milky Way's formation. And yet, even the stars, the gas, and the dust only account for a tiny fraction of the galaxy's mass. Holding the disk together, preventing the stars from flying off into the void, is a mysterious scaffolding we cannot see: dark matter. We know it's there because of the way the galaxy rotates. The stars at the very edge of the Milky Way are moving just as fast as the stars near the center. According to the laws of physics, they should be flying away, unless something incredibly heavy is holding on to them. This dark matter halo is the true skeleton of the Milky Way, an invisible structure 10 times larger and heavier than all the stars combined. Chapter 3. The Ghost in the Machine. Every star we see, every nebula we map, and every planet we discover is just a tiny fraction of the truth. If you look at a photo of the Milky Way, you are seeing the luminous galaxy, the glitter on the surface of a deep, dark ocean. But for decades, astronomers have been haunted by a realization. The vast majority of our home is invisible. There is a ghost in the machine, a silent architect that dictates the motion of every star, yet refuses to be seen. We call it dark matter. The discovery of this invisible scaffolding began with a puzzle in the 1970s. Astronomers, most notably Vera Rubin, began measuring the speeds of stars as they orbited the galactic center. Based on the laws of gravity established by Newton and Einstein, they expected a simple result: stars at the outer edges of the galaxy, far from the mass of the center, should move much slower than those near the core, just as Pluto crawls around the Sun compared to the racing speed of Mercury. But the data told a different story. The stars at the very edge of the Milky Way were hurtling through space at the same breakneck speeds as the stars closer in. By all accounts, the Milky Way was spinning so fast that it should have torn itself apart billions of years ago. The stars should have been flung out into the intergalactic void like water droplets off a spinning tire. Yet, the galaxy held together. There was only one conclusion: something invisible was providing extra gravity. Something incredibly heavy was acting like cosmic glue, holding the Milky Way in its grip. What is dark matter? To this day, we don't know for sure. We know what it isn't. It isn't stars. It isn't gas clouds. It isn't dust. If it were, it would emit or block light. Dark matter is something else entirely, a substance that does not interact with electromagnetic radiation. Light passes through it as if it isn't there. You could have a mountain of dark matter sitting in your room right now, and you would never know. It only reveals itself through gravity. Imagine the Milky Way is a glowing carousel. The stars are the riders, and the dark matter is the massive, invisible iron frame that the carousel is built upon. Without that frame, the riders would fly off into the dark. Current calculations suggest that dark matter makes up about 85% of the total mass of the Milky Way. Our island universe is actually a massive sphere, a dark matter halo, that is nearly 10 times larger than the visible disk of stars. We are effectively living in a giant, invisible bubble, and the beautiful spiral we see is just a small, bright decoration at the center. But the ghost does more than just hold us together. It was the midwife of the galaxy itself. Chapter 4. The Heart of Darkness. To find the true heart of our galaxy, we must travel 26,000 light-years inward, piercing through the thick veils of cosmic dust that hide the center from our eyes. As we descend into the galactic bulge, the stars crowd together, thousands of times more densely than in our own solar neighborhood. But at the very center of this stellar swarm lies a place of impossible physics. A place where a mass 4 million times greater than our sun is crushed into a single point of infinite density. This is Sagittarius A*, the supermassive black hole that anchors the Milky Way. For decades, Sagittarius A*, or SGR A*, was a mathematical ghost. We knew it was there not because we could see it, but because of the way it bullied everything around it. Astronomers tracked a group of giant stars, known as the S-stars, orbiting a patch of seemingly empty space. They were moving at terrifying speeds, up to 5% of the speed of light. Nothing but a supermassive black hole could have the gravitational grip to whip giant stars around like toys. But in May 2022, the ghost was finally given a face. Using the Event Horizon Telescope, a planet-sized array of radio dishes stretching from Antarctica to Spain, humanity captured the first direct image of the shadow of SGR A star. What we saw was a glowing ring of gas, superheated to billions of degrees, swirling around a dark abyss. This gas is moving so fast and is packed so tightly that friction turns it into a brilliant halo of radio waves. Inside that ring is the event horizon, the point of no return. Once anything, light, matter, or information, crosses that threshold, it is lost to our universe forever. SGR A* is not just a passive consumer. It is the galaxy's ultimate engine. While it currently sits in a relatively quiet state, it hasn't always been this way. High above and below the galactic plane, there are two colossal bubbles of gamma rays and X-rays, each stretching 25,000 light-years into space. These are the Fermi Bubbles. They are the scars of a violent feast. Millions of years ago, SGR A* likely swallowed a massive cloud of gas, or perhaps an entire star system. As it fed, it burped, shooting out twin jets of high-energy particles that blasted out of the galaxy like cosmic exhaust. This galactic feedback is what regulates the life of the Milky Way. When the black hole is active, the heat it generates can blow away the very gas needed to create new stars. It is a delicate, dangerous balance. The black hole provides the gravity to hold the center together, but its hunger can starve the galaxy of its future. If you were to fall toward SGR A*, time itself would begin to betray you. To an outside observer, you would appear to slow down, your image reddening and fading as you approach the event horizon, never quite appearing to cross it. But from your perspective, the universe behind you would seem to speed up, centuries passing in seconds, as the immense gravity warped the fabric of space-time. Eventually, you would encounter spaghettification, the tidal forces so strong that the gravity at your feet would be significantly more powerful than the gravity at your head, stretching your atoms into a long, thin strand before you are consumed by the singularity. Sagittarius A* is the ultimate paradox. It is the darkest object in the galaxy, yet it powers the brightest phenomena we know. It is a symbol of destruction, yet it is the anchor that keeps our galactic home from drifting apart. But the story of the Milky Way isn't just about the dark center. It's about the light that fights back. To see where the fire of the galaxy is lit, we must move away from the abyss and into the glowing clouds of the spiral arms. We have survived the black hole. Now, let's look at how the galaxy creates life. Chapter 5. Stellar Nurseries Narrator. While the center of our galaxy is a place of ancient stars and shadows, the spiral arms are the Milky Way's maternity wards. Throughout the disk, there are vast, cold clouds of gas and dust known as molecular clouds. To the naked eye, they look like dark voids in the sky, blocking the light of the stars behind them. But through the eyes of an infrared telescope, these dark patches reveal themselves to be the most vibrant places in the cosmos. Stellar nurseries. Starbirth is a battle between two of the universe's most powerful forces, gravity and pressure. It begins when a disturbance, perhaps the shock wave from a distant supernova or the passing of a spiral arm, jolts one of these massive gas clouds. Under its own weight, the cloud begins to collapse. As the cloud shrinks, it fragments into smaller pockets. In the center of each pocket, the temperature begins to skyrocket. What was once a cold mist of hydrogen becomes a protostar, a glowing, spinning ball of heat. Around it, a disk of leftover material begins to swirl, the raw ingredients that will one day form planets, moons, and perhaps life. When the core reaches a staggering 15 million degrees, the magic happens. Nuclear fusion ignites. Hydrogen atoms are slammed together with such force that they fuse into helium, releasing a burst of energy that pushes back against gravity. A star is born. One of the most iconic examples of this process is the Eagle Nebula, home to the pillars of creation. These towering columns of gas are 5 light-years tall, so large that our entire solar system would be a speck at their base. Within these pillars, newborn stars are carving out cavities with their intense radiation, acting like celestial sculptors. But stars are not all created equal. The Milky Way produces a vast variety of suns. The most common are the red dwarfs, small, cool, and incredibly long-lived. These stars can burn for trillions of years, outlasting the galaxy itself. Then, there are the Titans, the O-type blue giants. These stars are dozens of times more massive than our Sun and millions of times brighter. They are the rock stars of the galaxy. They live fast and die young. Because they are so hot, they glow with a brilliant blue light, illuminating the surrounding gas clouds and creating the breathtaking colors we see in the Orion Nebula. The Orion Nebula is the closest major star-forming region to Earth, located just 1,300 light-years away. It is so bright that it can be seen with the naked eye as the fuzzy star in Orion's sword. Inside, we see hundreds of stars in various stages of development, including proplyds, protoplanetary disks that are currently in the process of building new worlds. However, this beauty comes with a price. The very stars that light up the nebulae also destroy them. The intense stellar winds and ultraviolet light from new stars eventually blow the remaining gas away, shutting down the nursery. In a few million years, the Orion Nebula will vanish, leaving behind only a sparkling, open cluster of sibling stars that will eventually drift apart to find their own paths through the galaxy. This is the eternal rhythm of the Milky Way. Out of the cold, dark silence of gas clouds comes the warmth of a billion suns. We are part of this cycle. Every atom in your body was once forged in the heart of a star that lived and died long before our sun was even a spark in a nebula. But for the Milky Way to keep its fires burning, it needs a constant supply of fresh gas. And to get it, our galaxy has turned into a predator. We've seen how stars are born. Now we look at how the Milky Way survives by eating its neighbors. Chapter 6. Galactic Cannibalism. In the popular imagination, the Milky Way is a serene, majestic spiral floating in a lonely void. But the truth is far more violent. Our galaxy is a predator. For billions of years, it has survived and grown by hunting, stalking, and consuming its smaller neighbors. This is the era of galactic cannibalism. The Milky Way does not exist in isolation. It is surrounded by a swarm of roughly 60 smaller dwarf galaxies. These satellites are caught in our gravitational web, doomed to a slow, spiraling death. The process begins with tidal stripping. As a smaller galaxy wanders too close to the Milky Way, our immense gravity begins to pull on it unevenly. It's like a cosmic tug-of-war. The side of the dwarf galaxy closer to us is pulled harder than the far side. Eventually, the smaller galaxy is stretched and shredded, leaving behind a long, ghostly stellar stream of stars that wrap around the Milky Way like a scarf. One of our current victims is the Sagittarius dwarf spheroidal galaxy. It is currently being torn apart as it passes through the disk of the Milky Way. It has looped around us several times, leaving a trail of stars that spans the entire sky. In a few billion years, nothing will remain of Sagittarius except for its stars, which will be assimilated into our own disk, their original home forgotten. But the Milky Way wasn't always the giant it is today. We can see the scars of ancient meals through a field of science called galactic archaeology. By using the Gaia Space Telescope, astronomers have mapped the positions and velocities of over 1 billion stars. They discovered a group of stars moving the wrong way, in strange, elongated orbits. These are the remains of Gaia Enceladus, a massive galaxy that we swallowed 10 billion years ago. This collision was a turning point. It was so violent that it puffed up our thin disk and triggered a massive burst of star formation. We are, in a very real sense, a Frankenstein galaxy, assembled from the parts of the fallen. Right now, two of our largest neighbors are feeling the pull, the Large and Small Magellanic Clouds. These beautiful, irregular galaxies are visible to the naked eye from the southern hemisphere. For a long time, we thought they were stable satellites. We now know they are falling toward us at incredible speeds. As they fall, they are leaving behind a massive trail of hydrogen gas, known as the Magellanic Stream. This gas is the ultimate prize for the Milky Way. It is fresh fuel, pristine hydrogen that has never been inside a star. As the Milky Way's gravity sucks this gas into our disk, it will trigger a new baby boom of stars, keeping our galaxy bright and vibrant for billions of years to come. But cannibalism is a two-way street. Every time the Milky Way swallows a neighbor, its own structure is shaken. These collisions create ripples in our disk, much like a stone thrown into a pond. Some scientists believe the very spiral arms we admire today were shaped by these ancient and ongoing galactic mergers. We are a galaxy built on conquest. Every star you see might not have been born here. It might be an immigrant from a world that no longer exists. But even as we devour the small, we are being hunted by the large. Deep in the distance, a titan is watching us. A galaxy even larger than our own is on a collision course. The predator is about to become the prey. Next step for you. We've covered the Milky Way's diet. Next, we look at how the galaxy recycles its own material to create the building blocks of life. Chapter 7. The Recyclers. The Milky Way is not just a collection of stars. It is the universe's most sophisticated recycling plant. In the early moments after the Big Bang, the universe was simple, composed almost entirely of hydrogen and helium. There was no carbon for DNA, no iron for blood, and no silicon for the ground beneath our feet. The galaxy had to build these things from scratch, and it does so through a cycle of life, death, and violent rebirth. Every star is a nuclear furnace. Deep in their cores, they crush atoms together to create heavier elements. Small stars like our Sun spend their lives turning hydrogen into helium. But when a star reaches the end of its life, the recycling process moves into high gear. For a star 10 times more massive than our Sun, the end is spectacular. Having exhausted its fuel, the star collapses under its own weight and then rebounds in a titanic explosion, a supernova. In that fleeting second of explosion, the heat and pressure are so intense that they forge the heaviest elements on the periodic table: gold, silver, platinum, and uranium. The supernova then blasts these chemical seeds across the galaxy at millions of miles per hour. This enriched dust travels for light years, eventually drifting into the cold gas clouds we explored in earlier chapters. This is the interstellar medium, the smoke of dead stars. It is from this polluted, chemically rich smoke that new generations of stars are born. Our own Sun is a third-generation star. It was born 5 billion years ago from a cloud of gas that had already been enriched by the deaths of countless stars before it. Every atom of oxygen you breathe, every carbon atom in your cells, and the calcium in your bones was once cooked inside the heart of a massive star and scattered into the Milky Way by a supernova. As the astronomer Carl Sagan famously said, "We are made of star stuff." But the galaxy is picky about where it keeps its best stuff. This has led scientists to the concept of the galactic habitable zone. Just as a solar system has a Goldilocks zone, where it's not too hot and not too cold for liquid water, the Milky Way has a Goldilocks ring. If you are too close to the galactic center, the density of stars is too high. Frequent supernovae and radiation from the central black hole would sterilize any planet trying to develop life. However, if you are too far out in the rural edges of the galaxy, the gas is too pristine. There haven't been enough generations of stars to build up the heavy elements needed to make rocky planets like Earth that we live in the perfect middle ground. Our Sun sits in a quiet, chemically rich pocket of the galaxy, protected from the chaos of the core, but stocked with the ingredients for life. We are the beneficiaries of billions of years of galactic recycling. But the Sun isn't a stationary observer in this process. It is a traveler, embarking on a grand, multi-million-year odyssey around the galactic center, a journey that has shaped the history of life on Earth more than we ever realized. We've looked at the chemistry of the galaxy. Now, let's zoom in on our own backyard. Chapter 8. The Solar Suburbs. While we think of the Sun as a fixed point in our sky, it is actually a tireless traveler. Along with its family of 8 planets, the Sun is currently hurtling through the Milky Way at a staggering speed of 828,000 kilometers per hour. Even at this blistering pace, the galaxy is so vast that it takes us approximately 230 million years to complete a single circuit. This is the galactic year. The last time our solar system was in this exact spot in the galaxy, the first dinosaurs were just beginning to appear on Earth. We have only completed about 20 orbits in the entire history of our planet. We reside in a region known as the Orion Cygnus Arm, or simply the Orion Spur. It is a minor arm, a bridge between two of the galaxy's great highways. Astronomers often call this the solar suburbs because it is a relatively quiet, low-density neighborhood. Here, stars are spaced light years apart, protecting us from the gravitational tugs and lethal radiation found in the crowded inner city of the bulge. But our journey is not a smooth, flat circle. As we orbit the galactic center, the sun also bobs up and down through the plane of the disk, like a horse on a cosmic carousel. Every 30 million years or so, we pass through the densest part of the galactic disk. Some scientists believe these galactic crossings are dangerous times for life on Earth. As we move through the denser gas and dust of the disk, the Milky Way's gravity can nudge the Oort cloud, a vast shell of icy comets at the edge of our solar system. This nudge can send a rain of comets screaming toward the inner planets. There is a haunting correlation between our passage through the galactic plane and the timing of mass extinctions in Earth's fossil record. Our history has been written, in part, by the rhythm of the galaxy. Currently, we are passing through what astronomers call the local interstellar cloud. It's a slightly denser patch of gas about 30 light-years across. Before this, we spent millions of years inside the local bubble, a cavity of hot, low-density gas likely carved out by a nearby supernova millions of years ago. Our suburban location is the reason we can study the universe at all. Because we sit between major spiral arms, our view of the distant cosmos is relatively clear. If we were deeper inside a spiral arm, the thick clouds of dust and the blinding light of millions of nearby stars would make it nearly impossible to see the other galaxies that populate our universe. But even in our quiet corner, we are beginning to feel a change in the wind. The local group of galaxies, the small cluster of which the Milky Way is a member, is not static. Our neighbors are moving, and we are being drawn toward a massive gravitational anomaly known as the Great Attractor. We have spent 4 billion years in the relative safety of the solar suburbs. But the borders of the Milky Way are about to be breached. The long-range forecast for our galaxy is no longer clear and sunny. It is stormy. Next step for you. We've explored our neighborhood and our journey. Now, it's time to look at our cosmic companions. Chapter 9. The local group. To truly understand the Milky Way, we must look beyond its borders. Our galaxy is not a lone wanderer in the dark. It is the dominant member of a small, cosmic neighborhood known as the local group. This is a collection of more than 50 galaxies, spanning roughly 10 million light-years of space. In this neighborhood, there are two undisputed heavyweights, the Milky Way and our sister galaxy, Andromeda. To truly understand the Milky Way, we must look beyond its borders. Our galaxy is not a lone wanderer in the dark. It is the dominant member of a small, cosmic neighborhood known as the local group. This is a collection of more than 50 galaxies, spanning roughly 10 million light-years of space. In this neighborhood, there are two undisputed heavyweights, the Milky Way and our sister galaxy, Andromeda. The local group is held together by gravity, a tight-knit family in an expanding universe. While most galaxies in the universe are flying away from us due to the expansion of space, the members of the local group are bound together. We are an overdensity in the cosmic web, a pocket of matter that has resisted the pull of dark energy. But there is a tension in this family. For billions of years, the Milky Way and Andromeda have been performing a slow, gravitational ballet. We are falling toward each other at a speed of 400,000 kilometers per hour. It is a cosmic game of chicken, and neither galaxy is going to blink that we move through the local group. We see the Magellanic Clouds, the two largest satellite galaxies of the Milky Way, hanging like ornaments in the southern sky. They are being cannibalized, as we learned, but they also serve as a warning. They are the heralds of what happens when the balance of power shifts. The local group is our immediate horizon, but even it is part of something larger. We are being pulled toward the Virgo supercluster, a massive city of thousands of galaxies. And beyond that, everything in our region of space is hurtling toward a mysterious gravitational anomaly called the Great Attractor. We are part of a vast, flowing river of galaxies, a structure called Laniakea, Hawaiian for immense heaven. In this grand map, the Milky Way is just a speck of light on a single branch of a cosmic tree. But even as we contemplate this infinite scale, we must return to the impending drama in our own backyard. The peace of the local group is temporary. The two giants, the Milky Way and Andromeda, are destined to become one. The era of the spiral galaxy is coming to an end. Next step for you. We have reached the edge of our neighborhood. Now, it is time for the final act. Chapter 10. The Last Dance. Every story has an end. For the last 13 billion years, the Milky Way has been a masterpiece of order, a spinning disk of light, a nursery for stars, and a cradle for life. But the laws of gravity are patient, and they have decreed a transformative fate for our home. The Silver River is on a collision course with a titan. In approximately 4 billion years, the Milky Way will cease to exist as we know it. This is the story of the birth of Milkomeda. Right now, the Andromeda Galaxy is 2.5 million light-years away, appearing as a faint smudge in the night sky. But as the eons pass, it will grow. In 2 billion years, it will be a distinct spiral, larger than the full moon. In 3.75 billion years, it will fill the horizon, a second, massive ghostly river of light stretching across the sky, its gravity beginning to tug at our own stars. When the collision finally begins, it won't be a sudden crash. Galaxies are mostly empty space. Because stars are so far apart, the chance of any two suns actually colliding is practically zero. Instead, the two galaxies will pass through each other. But while the stars survive, the structures do not. Gravity will tear the beautiful spiral arms apart. Massive tidal tails, long ribbons of millions of stars, will be flung out into the intergalactic void. The gas clouds of both galaxies will slam into each other, triggering a final, spectacular fireworks show. A burst of star formation so intense that the night sky of Earth, if anyone is left to see it, will be ablaze with thousands of new, brilliant blue stars. For 1 billion years, the two galaxies will dance, swinging around each other in a gravitational embrace, pulling and stretching one another. Eventually, they will lose their momentum and settle into a single, massive shape. The result will not be a spiral. It will be a giant elliptical galaxy. Gone will be the majestic arms and the dark dust lanes. In their place will be a soft, glowing ball of trillions of aging stars. Astronomers have already given this future home a name, Milkomeda. And what of our sun? By the time the merger is complete, the sun will be much hotter and brighter, likely having rendered Earth uninhabitable long ago. During the collision, our solar system might be flung out into the far reaches of the new galaxy's halo, or perhaps even ejected into the lonely darkness between galaxies. We will be spectators to the end of an era. Ultimately, the black holes at the centers of both galaxies, our own Sagittarius A*, and the even larger black hole at the heart of Andromeda, will find each other. They will spiral inward, sinking to the center of Milkomeda, and merge in a final, titanic burst of gravitational waves that will ripple through the very fabric of the universe. The Milky Way's journey from a small cluster of primitive stars to a galactic superpower is a testament to the creative power of the cosmos. We are the consciousness of this galaxy. The way the Milky Way looks at itself and tries to understand its own origin. As we look up at that white ribbon of light today, we are seeing a moment in time that is both ancient and fleeting. We are the children of a galaxy that is living, breathing, and moving toward a grand, inevitable union. Our home is vast, our history is violent, and our future is spectacular. In the end, we are all just travelers on the Silver River, drifting toward a sea of stars.